Thanks for coming. The topic of today is JUnit 5, new opportunities for testing on the JVM. So my name is Sam Brannen, and I'm a Spring and Java consultant at a company called Swiftmine in Zurich, Switzerland. And I'm a trainer and a coach, but a hardcore developer at heart. And I've been a Java developer for about 20 years, as well as a core committer for the Spring framework since 2007, when I took over the testing support and rewrote or invented the Spring Test Context framework, which you might perhaps be familiar with. And since October 2015, I've also been a core committer for what we call JUnit 5. So Swiftmine, we're experts in Spring and Enterprise Java. If you'd like to get in touch with us, you can contact us on the internet. So the agenda, first up, we're going to talk about the impetus for change, why we have a new version. Then we'll talk about JUnit 5 in detail. I'll do some demos and some live coding. And then I'll have a little bit of time at the end to talk about some of the support in Spring 5 for JUnit 5. And then if we have time, Q&A, and otherwise, just find me afterwards. So show of hands, first up. Who writes tests, I guess? Everybody, all right. Who writes unit tests? Yeah, everybody. Integration tests? Oh, a lot. Okay, like system tests, end-to-end tests, stuff like that as well? Fewer people, okay. Who uses JUnit? Pretty much everyone. JUnit 3, anybody? Oh, one or two. JUnit 4, yeah, I guess, most people. 4.12, latest version? Not as many, okay. Anyone use anything like TestEngine? Yeah, a few people. Spock, anyone out there? A few people, okay. All right, just interested to see what kind of people we have here. So first up, why do we have a new version of JUnit? Impetus for change. So JUnit 4 was released a decade ago, and a lot has changed since then, right? So our needs have matured, the things that we expect from the framework. And JUnit 4 was also well, kind of a big ball of mud, right? It was just the one single JUnit jar, and that made it harder to maintain and to extend it. Also, the test discovery and execution are just tightly coupled in that architecture. And in terms of extensibility, there's lots of room for improvement in JUnit 4. So, and let's not forget about versions of Java, right? So Java 8, Java 9, 10, 11, everything coming up, right? So JUnit 4 is still based on Java 5. So JUnit 4, there's the runner API you might be familiar with if you've ever used Spring's testing support, right, the Spring runner. So that's very powerful. In fact, it can do anything, but you can't combine runners. It's just not possible. For example, if you ever wanted to use the parameterized runner from JUnit 4 and the Spring runner from Spring, it wasn't possible to use them at the same time. So what I like to say is that JUnit 4 rules, maybe, but rather JUnit 4 rules are meant to be broken, and basically they always were. So originally there was the runner, and then they brought in the rules in JUnit 4.7. There was a method rule. Then they brought in a test rule that could be used method level and class level in JUnit 4.9. So those are great for simple use cases, and you can even combine them. It was designed that way. But a single rule can't be used for both method level and class level callbacks, which is rather a shame. Plus, there's zero support for what I call instance level callbacks, so for like dependency injection, stuff like that. So case in point, if you know Spring, I had to implement two rules in Spring, Spring class rule and Spring method rule, if you want to have the full support there. So that's somewhat annoying. So what did we do? We had a crowdfunding campaign with Pivotal as one of the main sponsors, actually the primary sponsor. It was initiated by Johannes Link and Mark Philipp, and then later joined by a couple other German guys, Matthias, Stefan, and I joined the team as well. Ran from July to October 2015. We raised a bit of money, got us started, and 4 companies donated 6 weeks developer time. So if your name's up here or your company, then thank you very much. And from there, what we did is we had a kickoff meeting with some individuals, some developers from Gradle and Eclipse and IntelliJ, and also from these other companies. And we basically decided what the roadmap should be for JUnit 5. So what we did is we first built a prototype. And then we had a big alpha release based on feedback from that. We had a couple of milestones, about 6 milestones, a couple of release candidates, and released GA back in September of this year. 5.01 also released that, 5.02 more recently, so if you want to use the latest and greatest, that's the one to use. If you want to be on the cutting edge, you can check out 5.1 milestone 1 or snapshots, what we're working on right now. So what is JUnit 5 in a nutshell? It's modular, at least we like to think so you see that in the architecture. It's extensible, a lot more than JUnit 4 was. Modern, at least, right, based on Java 8 and things like that. And another key point that we want to keep in mind there is we want to make sure it's both forward and backward compatible at the same time. So what I mean by that, basically on the JUnit platform, which we'll talk about in a minute, that supports JUnit 3, 4, and 5 all at the same time. So you can run all those tests and have them all reported together at the same time. In addition, new testing frameworks can be run with the old JUnit 4 infrastructure. So for example, based on this runner principle, if you use @runwith, you can say @run with JUnit Platform, and basically it starts up, you start up JUnit 4, and that starts up JUnit Platform, which then can then run other testing frameworks like JUnit 5 or something else. So in terms of versions, right, so it's based on Java 8, so you need Java 8 in order to use JUnit 5. But you can also use it to test application code written against other JDK versions. So maybe you're still using Java 6 or 7, right? But for your tests, you can write them with Java 8. Java 9 support works fine on JDK 9. You might have seen that tag around from Java 1. In fact, all of the artifacts have a stable automatic module name, so you can have them on the module path if you want. And we're adding, or we already added in actually in 5.1 M1 support for scanning in the module path, in addition to scanning in the class path to find your test classes. And Java 10, not too much to say there, other than we actually have some builds. We just added that in recently, so we're trying to make sure that everything's going to work there as well. So, JUnit 5, my joke here is there is no spoon, there is no JUnit 5, and what I mean by that is that you can't upgrade from JUnit 4 and just change 4.12 to 5. That's not going to work because we rewrote everything. And actually what we did is we ended up starting with kind of one project called JUnit Lambda, and over time we realized we're inventing three things, three separate entities, and so we ended up with the platform, Jupyter, and Vintage. So the platform was released at version 1.0, and that's a new foundation for the JVM in general for launching any kind of testing framework. And it has some launcher and TestEngine API extractions there. So we also have a console launcher, support for Gradle and Maven as well. And then JUnit Jupyter, that's 5.0, so that's what you might consider JUnit 5. That's the new programming and extension model with this new release. So Jupyter, people ask why. It's the fifth planet from the sun, and it just happens to start with JU, so it kind of has a nice ring to it. All right, so JUnit Vintage, I proposed to call it Legacy and Retro and some other things, but eventually ended up calling it Vintage. So that's just the support for running JUnit 4 and JUnit 3 on the platform at the same time. So the first part is actually revolutionary. That's never really existed before. You might consider JUnit 4 to have been like that, but it wasn't designed like that. People did write other testing frameworks with the JUnit 4 runners and stuff, but it was really geared towards the Java programming model. Right, so but this new platform, you can write any kind of testing framework. It could be file-based, based on JSON, XML files, stuff like that, or Java classes, closures, and stuff like that. So it's really kind of a generic basis for building any new testing framework. And the next part is evolutionary, right? So it's building on the experiences with JUnit 4, but then adding in support for things like Lambdas and other stuff like that. And then, of course, the last part is just necessary in order to allow people to migrate or run existing test code bases alongside newer testing frameworks. So what is this launcher API? It's used to, as you might guess, launch the framework. So it's so analogous to the JUnit core in the past, and that's what IDEs and build tools will use, but you could use it programmatically if you wanted to. There are people who use it in a main if they have some custom needs. And that's the central API for discovering and executing tests via one or more engines. And for that, there's a request you can build up with the builder pattern there, and you have things like selectors and filters. So you can select like packages to scan in, you can select particular classes, particular methods and stuff like that. Or for another testing framework, you could select a file from the file system or a file from the class path and stuff like that. And filters, you can filter out stuff based on like tags or class name patterns, package patterns, and stuff like that. And then there's a listener API you can tie into if you want to get information as the test plan is executing, and that's how IDEs and everything tie into it, but you can also create your own custom listeners. So if you want to run from the command line, you can do that with the console launcher, and that has command line support for the same features in the launcher discovery request. So next up, this TestEngine API. That's kind of like the runner from JUnit 4, but again, it's more general purpose, more generic. And that's supposed to basically discover tests for a particular framework and then execute them. So there's two phases: to discover stuff and then to run this test. And again, for a particular programming model, so like there's one for running with the JUnit 5 stuff, it knows about the JUnit 5 annotations, whereas the one for JUnit 4 knows about the JUnit 4 annotations. And that also answers the question why we have a new package. You'll see that in a minute for tests. So there's two test annotations now. Right, and these can be registered automatically via Java's standard service loader mechanism if you want to go that route. That's how it works. There's the Jupyter TestEngine. Out of the box, we have that for the new stuff. And we have Vintage TestEngine for the old stuff. So your JUnit 4, JUnit 3 can all run at the same time. And you can implement your own. In fact, people have done that. If you check out this, this wiki page, we have a third-party extensions page in the wiki, and you see there's some stuff there. So Spexy, some developer out there wrote support for, I guess it's Scala, Groovy, and Java at the same time. Spec is for Kotlin, Cucumber stuff, and there's some other ones, and people are developing more as time goes on. So it really lowers the barrier for anyone who actually wants to experiment with writing a testing framework. You can write your own and have it run in the same infrastructure that all of the other stuff runs on. So it'll run in the IDEs and in your build tools automatically, which is pretty cool. So the big picture, here we have it in the middle, the platform, right, the big section in the middle. And then below that, we have IDEs and build tools that are interacting directly with the platform, but not directly with the engines. And then we can have one or more engines that are registered. So for example, you could have the vintage support there to run JUnit 4, Jupyter to run new stuff, or something like this Spexy framework that I mentioned, any other third parties that can all tie into that. And if we look behind the scenes, what we see there is that in the middle there, we have this, the platform launcher, which is what the build tools and stuff are going to use, as well as our plugins for Gradle and Maven. And then you have the platform engine itself and the APIs there. And then each of the third parties, or even JUnit itself that wants to tie into that, you basically implement the test engine, right? And then you know how to find your own tests and execute them, and everything gets aggregated together in the reporting and within the platform. So you see that's a much different architecture from what we had with JUnit 4. JUnit 4 was literally one jar, and you can see here each one of these boxes is a jar or a separate module on its own. So IDEs and build tools support. IntelliJ was the first, supporting the platform since 2016.2 and more recent versions as well. Eclipse also has official support since September, and Eclipse Auction 4.7.1a. And NetBeans, I have no idea. There's been an issue, but not much response there, so we'll let the monkeys speak for themselves. In Gradle, we have an interim solution that we've written, and we're also having conversations right now with the Gradle team to get something out of the box from Gradle itself over the course of the next couple of months, hopefully before mid-2018, finally, in Gradle itself. Yes. So Android support, a nice gentleman has written support for that, and I have a link here. The slides will be available online later, so if you want to check that out, there's support for running tests with Gradle with Android as well. And Maven, we also have an interim solution there, which we have donated the code to the Maven Surefire team, and they're hopefully taking that forward from where we started. So basically, at this point in time, you can run stuff in Eclipse, you can run stuff in IntelliJ, and you can run stuff in Gradle and Maven. So those are most of the use cases there. Ant, we don't have Ant support, but it's been requested. So if you want to, you can develop that and commit it. So don't have time to show that today, so if you want to see examples of that, just check out the user guide. We also have some sample applications in a separate repository showing how to set all these things up for the build. So what is JUnit Jupyter? So I mentioned there's two things, right? It's a new program model, an extension model, and let's look at that part first. So we have an extension API. It's just a marker interface, and that's in the org JUnit Jupyter API extension package. And that contains all of the extension APIs or callback APIs and stuff like that. So the nice thing is you can implement as many as you like. So I mentioned before with the rules you couldn't implement both, but with JUnit Jupyter you can implement as many as you like. And for example, the Spring extension implements I think about 9 of the 13 or so at the time. So with JUnit 4 we had run with because it was a runner, and with JUnit Jupyter we have extend with, and you can provide one or more extensions, so the classes that you want to have used there. And as I mentioned before, you can combine multiple at the same time. So you could have like Mockito and Spring or something else all at the same time. And where can you declare that? You can declare it obviously on classes and methods, but also on interfaces, which is something new in JUnit Jupyter as well. And you can use it as a meta annotation. And we'll see an example of that later with Spring support. So Spring has supported meta annotations for a long time, and now JUnit 5 does as well. So in terms of these APIs, we have several options there relating to the user code, right? User code, we'll see some annotations that relate to these things. We have wrapping around, so before all callback and after all, that's at the class level. And then before each and after each, that's around the test methods. But then there's even one lower level directly around the invocation of a test. So there's before test execution and after. And that would be in order to, for example, to time the execution of the test method itself. So that's lifecycle callbacks. And then we have support for handling exceptions. If you wanted to implement your own expected exception kind of extension, Execution conditions, we'll get into more detail later on, but that's what we call conditional test execution. Test instance post-processor. If you use Spring, you might have heard of the bean post-processor, so this is a similar concept, and this is where you perform dependency injection. And the other part here, parameterized, that's also inspired by Spring MVC support. You might have used Spring MVC before and seen you can have multiple different parameters coming from different places, and we support that in JUnit Jupyter as well. So again, these two are the dependency injection, and then the last one is more complicated, the test template invocation. That's for things like repeated tests and parameterized tests. So for the programming model, that's all in the org JUnit Jupyter API package. Do not pick stuff from org JUnit. The test annotation, it won't work if you're using JUnit Jupyter. And then there's a separate module for the parameterized support in JUnit params. So we have lots of stuff. We have annotations and support for meta annotations, assertions and assumptions, custom display names, something new. Visibility, things don't have to be public anymore. They can be protected or packaged private. They just can't be final, right? So, can't be private. Tagging, we have that. So JUnit 4 had categories, and we have full support for tags in the platform in JUnit Jupyter as well. Conditional test execution, dependency injection, not only for your test methods, but also for your lifecycle methods like before each, and also for constructors, which is something quite new in the JUnit 4, JUnit 5 world. So we also support for Lambda expressions and method references, interface default methods with Java 8, nested classes, we'll take a look at that, and repeated parameterized tests, and even dynamic tests with Lambdas. So annotations, just kind of a whirlwind overview here. So we have a test annotation. We couldn't come up with a better name, so we just called it test, but it lives in another package. And test factory for dynamic tests. And if you're implementing your own engine, you would want to take a look at the testable annotation as well. So repeated tests, parameterized tests, we have that. They are specializations of test template, nested tests, test instance. So in JUnit 4, you may be aware or may not, every time you have a test method that's executed, JUnit actually instantiates your test class again. So you always get a new instance. TestEngine does the exact opposite of that. And with JUnit Jupyter, we allow you to choose which mode you want. So you can do test instance per test method, that's the default, or you can change it to per class, and then JUnit Jupyter will cache the test instance. That's also nice, makes it much nicer to program in languages like Kotlin if you're using Kotlin to write your tests. So before all and after all, that's like before class and after class. Before each and after each, that's like before and after from JUnit 4. Display name allows you to define a custom display name. Tags and disabled. So we had at ignore in JUnit 4, and in JUnit Jupyter it's called disable, and it'll make more sense when I talk about the extension model for that in a bit. So in terms of the rules, in order to make it easier to migrate existing test bases, we do in fact have limited migration support for JUnit 4 rules. You just annotate your test class with add enable rule migration support, and that will automatically register 3 extensions by default. One is the external resource support for things like temporary folder rules from JUnit 4, verifier support for things like error collector, and expected exception support if you're using expected exception as a rule in JUnit 4. You can actually use these kind of rules in JUnit Jupyter or JUnit 5. The other kind of rules don't work because the model is different, so we only can support these particular types of rules. So yeah, there were some minor bugs in 5.0. If you're using the latest and greatest, those bugs have been fixed, 5.02. So assertions, that's in a new assertions class. It's no longer called assert. Limited set of core assertions like you had in JUnit 4, stuff like assert equals not null, but also support for Lambda expressions. So the new way to check for exceptions is with assert throws. And for timeouts, the new way to do that is to use assert timeout and assert timeout preemptively. So timeout will just let the code run, and then afterwards check how long it ran, and then throw an exception if it took too long. And assert timeout preemptively will preemptively kill it off, right? It'll execute in a separate thread. So you need to keep in mind if you're using something like Spring or some other framework that's storing things on a thread local, then that information wouldn't be visible. So if you had some kind of transactional support from Spring's testing support, transactional test, and then you ran a block of code preemptively with a timeout, then it would run a separate thread, and that would mean the Spring transaction wouldn't work. So keep that in mind. Assert all. It's a cool feature, and it's surprisingly very popular with a lot of people. It's like soft assertions and assert J, so you can assert multiple things at the same time, and JUnit Jupyter will track all of the exceptions thrown and then just report all of them at the end. So you don't have to run your test 30 times and fix the first one and then fix the second one and fix the third one, right? You can see them all the errors at once, and maybe discern figure out what the bug is and fix it all in one go. We also support suppliers of string for messages, so lazy evaluation of the messages, right? If you have messages that are being concatenated or built up with extra information, you don't want to slow down your tests with that, so just supply them via supplier Lambda expression. And the message is now the last parameter because it's typically optional, but that might be a gotcha for some people. So if you don't like the stuff in core, that's fine. We also use AssertJ within our own testing suite in JUnit, so if you want to use AssertJ, Hemcrest, Truth, and stuff like that, that's fine. All those things are going to throw exertions and fail your test in any case. So assumptions, that also comes from JUnit 4, right? There was the assume class, and we have assumptions allowing you to abort tests mid-flight, so it means the test has already started, but you can decide on something, oh, this value isn't there, or this file isn't there, so it doesn't make sense to keep running the test, so you can abort it mid-flight. And otherwise, if you wanted to skip it entirely and not even start executing it, you would implement or use an execution condition, and we'll talk about that more later on. So we have stuff like assume true and assume false, but there's also take Boolean suppliers and suppliers of strings if you want. And we have something that's kind of like a glorified if block with more semantic meaning. So assuming that this block evaluates the true, then execute this code, and otherwise just continue on and skip over the execution. So I will now hope that when I touch my keyboard, it's not going to disconnect the HDMI. Keep your fingers crossed. All right. So for starters, we have a very exciting calculator class, right? It can add, subtract, multiply, and divide. Divide could divide by 0, and Fibonacci could take a long time, depending on which number you asked for, right? So no real surprises there, but we're going to see that tested first as a JUnit 4 class. And assuming that runs, let's just check it out. It should be green. That's green. OK, so the calculator is subject to the test. We're using a couple of rules here. We got the expected exception rule and a timeout rule for the Fibonacci one. And then we have some various assertions for adding, one with a message. We have a division by 0 expecting arithmetic exception, right, with the rule support. And then the Fibonacci, so if we wanted to make this one actually fail, you know, if we made it bigger, then on my computer that generally takes longer than a second. And it did, so right, we see the timeout there from the test rule. So what if we wanted to convert that to JUnit Jupyter? We can make a copy. See, I even typed the U big. That's how often I type JUnit. JUnit, JUpyter. All right, here we go. OK, so what's the first thing we want to do? Well, the imports are wrong, right? So let's get rid of these, at least the test rule, the test annotation. So let's pick that and pick the one from JUnit Jupyter API. So that should be a start. The next thing we want to do is, or if we want to, we can get rid of stuff like public, but not on the rules. They still have to be public. I've made that mistake before. But the methods in the class, they no longer have to be public. So you can type less. So what happens if we run this at this point? We see some errors. The first one is divide by 0, right? So it actually threw the exception, and that means this expected exception rule didn't kick in. So I mentioned there's this migration support. That enable rule migration support. And if I run that, hopefully it will now pass. All right, so that's a good step there. And the timeout, right? So if we change this to 42, it's just going to run longer, right? So that rule is actually not supported. So I mentioned we only support certain types of rules. So let's get rid of the rules then and go for a full migration. So let's get rid of that. And this one, let's do that one first. All right, so it won't compile. And what do we have now? Anyone recall how I said you do this? How do we check for exceptions? Assert throws, if I can type, but you can't. Stop. Assert throws. My computer, let's type this slowly. Okay, that looks better. So the type is that, and what is it that we expect to throw the exception? This part, right? So how do we supply that? As a Lambda expression, right? So far so good. And that's the error message we're gonna expect later on. So let's just check out this method if we run this now. that passed. So it actually threw the exception, and this is the Lambda expression. You could of course have a block there or a method reference if you want. And if you want to get hold of the exception, you can just assign it to a variable. No big challenge there. Oops, what happened? And then you can assert equals, for example, that the expected is equal to exception get message, right? And if we rerun that, that works. Okay, so that's how we do exception testing in JUnit Jupyter. And for the timeout, we're going to have to do that quite differently, right? So if we run this thing again, it's still just taking a long time with the Fibonacci, and we want to actually add that timeout in. So how does it do we do that? Anyone paying attention? Assert timeout, for example, of maybe milliseconds from duration, 1,000. That's the thing we want to execute, but we need to make that a Lambda expression. If Eclipse will let me do that. Okay, so now if we run that, what is it going to show? Now it ran 1.3 seconds, right? Right? If I can scroll. But it said, as the error exceeded timeout by about 400 milliseconds, right? So that was the normal way, non-preemptive. So let it keep running and it just timed it. And what if we want to kill that early? How do we do that? If we want it to die off early, then we would say preemptively. So now if we run it, it should stop immediately after a second, yeah, right? So 965, sounds pretty good. Execution timed out after 1,000 milliseconds. So again, you have the options there, just bear in mind that the latter one actually starts or runs the block in a separate thread. Okay. All right, oh, I didn't make that one non-public, that's fine. There we go. So we see we've gotten rid of all of the JUnit 4 imports should all be gone now. All the tests should run, except for the timeout should fail, that's right. So we've done everything we expected there. So again, using stuff from assertions in JUnit Jupyter, assert equals, it's not the one I wanted, but it, as again as mentioned, doesn't matter which assertion you take, so you could take that one from assert.j or wherever. Okay, so moving right along. Next up, tagging. So you can declare @tag on a test interface, class, or method. For example, we have here @tag test, and combining that with test. So we're saying this is a fast test. By default, the tags are ignored. You have to either tell the tags to be included or excluded in order for them to be honored. So you can also have custom tags, right? I mentioned the support for meta annotations. Sorry. So if you declare @tag as a meta annotation, so on top of another annotation like this, you could have that target method and say @tag fast. Then you can use this fast annotation across your code base instead of having to type in fast all the time, or maybe you change the name of the tag, right? So you could say fast test like this, quite convenient. But you can even go one step further. So you can have custom composed tags like with Spring. So you can declare @tag as a meta annotation along with other annotations from JUnit or from Spring, which is super cool. And you can combine them into your own custom composed annotation. So here we have an example with @tag fast and @test, and we call this thing fast test. So then we can just rewrite the previous test like this. So you can have like fast test, but you could also have like an integration test or transactional integration test, and you can combine like transactional from Spring, various annotations from JUnit, et cetera. So a lot more power there in terms of not repeating your configuration. So test names, right? Names by default will be the technical names of the class or the method. Those characters are going to be limited based on the Java syntax. Of course, different if you're using something like Groovy or Kotlin, but in Java based on the Java syntax. So we have the support for custom display names with @displayName, and that can contain spaces, special characters, and even emoji. So we didn't aim to support emoji, it just happens to work. All right. Dependency injection, we have support for that. And that's where I like to say that the extension model meets the programming model. So the extension model empowers you in your programming model. And for that, we have this parameter resolver extension API. Some are implemented by the framework itself. You can also implement it yourself if you want to. And what it does is it resolves a parameter for test and lifecycle methods, and also for constructors. So you can register multiple of them at the same time, but only one of them can win. If there are multiple that say they support the same thing, then you get an exception, because otherwise JUnit wouldn't know what to do with it. So typical use cases, if you want to inject something like the server URL or a port number, something like that, maybe a data source, maybe a Spring Application Context, or a bean from CDI or from Spring Application Context, that's why you would probably want to use that. So test info, that's from the framework itself. You can inject that into your constructor, at test, at before each, et cetera, and you get access to things like the display name, tags, class, and method, and stuff like that. And for that, just behind the scenes, there's a test info parameter resolver. So one of the ideas or goals we had with JUnit 5 is that whenever we have a feature, we like to make it available to everyone. So we implement or design an extension point, and we implement it ourselves, but then that allows other people to also implement it. So it's not like there's limited power. For example, the @ignore annotation, that was limited to JUnit 4, and we'll see with JUnit Jupyter, everyone can do something similar. So see some other examples in the framework itself. Repetition info for repeated tests, the test reporter for adding additional reporting information for your test, key value pairs. The Mockito extension is an example we provided, and the Mockito team is actually taking that over, so they'll have an official one eventually. And surprise, there's a Spring extension as well, right, that allows you to have dependency injection from Spring Application Context. So this add disabled thing, right? So what's the significance of that? This falls in the category of what we call conditional test execution, and it's another place where the extension model meets the programming model. So for that, there's an execution condition API you can implement, and it basically determines is something disabled or enabled, right? So hence the name disabled. It makes more sense in that context. And for that, we have built-in support for @disabled, and behind the scenes, there's a disabled condition. It looks to see if the annotation is there on the method or the class to determine whether or not the test should run or not. So this is what I like to think is a game changer. I think a lot of people are going to really start using this. We've already seen some examples. So in the past, we had these assumptions with JUnit 4, and we had @ignore, right? But now we have the ability to write our own kind of custom annotations. So you can say disabled on Mac, or enabled on Windows, or enabled on CI server, or disabled on weekends, and you can implement anything you want based on anything programmatically. So you really have a lot more power than we've ever seen before in this idea of conditional test execution. And with these things, you can also actually deactivate them. So maybe you have a bunch of disabled things, or maybe you have things that only used to run on the CI server. Maybe they run locally now and you want to check it out. So you can disable all the conditions with the startup parameter system property or within the JUnit Platform properties file, and then those things will be ignored, and you can see those tests pass in a different environment and stuff like that. So you set that by JUnit conditions.deactivate, and then it's a kind of a wildcard pattern based on the package and then the class name. So some more coding. Tags, display names, dependency injection. All right. Super long class name, like we love it in Spring, right? I'm a core Spring committer as well, so I'm allowed to write crazy long names. All right. Does those run, right? And we wanted to make it a fast test. So I said we could say tag fast, like that. And if I run it again, we'll still see that there are 2, that says 2 of 2, right? Because I said we didn't turn on the tags, include or exclude anything. And Eclipse, I should be able to go to run configurations, and they have support for include and exclude tags. And I have this exclude tag, so I can say exclude fast, okay, apply, and run. And now we'll see there's only one test, right? So it doesn't even get reported because it gets completely ignored and filtered out of the test plan before anything happens. So we see that in action there. And we also have this fast test, which I talked about here. So annotated like that, @tag fast and @test. And then we can just replace this with fast test, right? Run it again, and it should have the same effect, right? So 1 to 1, so that one got ignored. So we see that, that's the tags. Now for display names, we can have display names at the class level, right? We can also do that at the method level. Special characters. And if we run that now, we should see, I'll zoom this in a bit. Right, so it's taking the custom names now. But if you double click, it'll still go right to the method anyway. So behind the scenes, it obviously tracks the methods and the classes, but you can give them custom display names. And the other part, which is difficult in Eclipse, but I can usually do it like this. So you can't type emoji in Eclipse, but that doesn't stop you from copying and pasting emoji into Eclipse. So now, there it is. Everyone's favorite example. Yay! Emoji. Awesome. So I have the command line open as well, and if I run the tests with the Gradle plugin, and I have it printing out the tree of the results, we should see an emoji somewhere up there as well. So yes, there we go. So it even shows up in your CI server in the command line, if you're so lucky. I know, it's the most important feature of JUnit Jupyter. But again, we did not design that. Someone complained on Twitter that we were stupid for supporting emoji, and I had to correct them and say, we don't support emoji, it just works, right? I mean, we support exclamation marks or special characters, and then emoji is just another special character. Okay, so dependency injection. So what if we want to get information about the test running? We could pick test info, have that injected, and I'm just lazy. I'll just print it out for you. Yeah, come on. Okay. So now if I rerun that, will you see something in the console? We do. Oops. So we see the display name with the emoji, the tags. There weren't any tags on that one, but you see the test class is there and the test method is there. And you can use this information if you want to, maybe for some custom reporting or something else. And conditions. So if we wanted to just disable that one, right? We could just say disabled. Easy enough. And we should see now my normal test is disabled yet, so that's why it's grayed out. It didn't actually execute. So 1 of 1, but it says 1 skipped there. And in terms of the other stuff, I'll show this later on, but just the kind of the power. I'm running on a Mac, and if I run this test again, you can come up with anything you want. That used a bit of Spring stuff in the magic in the background, but it's also disabled because this is a Mac. So this is this conditional test execution support. But I'll show you the code for that later on. Okay. Alrighty. So testing traits. We don't really have traits in Java, right? Some languages have stuff like that. But we do have interface default methods as of Java 8, right? So this enables the concept of what I call test interfaces or testing traits. So you can have multiple inheritance in your tests, right? So default methods can have behavior. And I've already mentioned before, you can have annotations on interfaces and stuff like that as well. So you can have stuff like at before all and after all. They can be, they're static by default. But if you annotate your interface with @TestInterface lifecycle per class, I mentioned you have that choice then you can also declare these as default methods, right? Because they're no longer static. Before each and after each, that works. And then all the other tests types, so @test, repeated test, parameterized, test factories, et cetera. You can declare all that stuff as default methods, and then you can implement multiple interfaces and pull that information, and you can also have tags, register extensions, et cetera. And we'll take a look at the string tests in the user guide to see that in action. So this is straight from the user guide, and we see if I run this, we see there are tests. But if I look in this class, there are no tests, right? There's no test methods, but they implement interfaces. So if I were to double click on one, it should jump straight to one of them, and we see that's in this composable contract. And it does in fact have test methods, and they are default methods. So the string test implements a couple of different ones. So you can basically have these traits. If you have stuff you want to test like equal support, comparable support, hash code support, and this kind of stuff, you can kind of implement the logic generically once. And like for the equals contract, it also has an abstract method, create the not equal value, right? So to create something else, and that extends testables. So you have new options for how you define your test suites these days. Okay. So next up is nested tests. So there were some custom runners, 2 custom runners that I'm aware of for JUnit 4 that allow this. And we now have this out of the box with JUnit Jupyter. So you can have logical hierarchical groupings of your test classes as nested test classes, and you can have shared initialization and state from the outer instances of those test classes. So the way you do that is you just declare a non-static nested class as @nested, otherwise known as an inner class. And you can even combine these nested classes with these testing traits and test interfaces if you want to as well. So for that, we have the testing a stack example in the user guide, and I'll show that one as well. So if we look in here, and another combination people like to do is use @displayName in nested test classes, because then you get kind of like a BDD style, even though you're using classes in Java here. So we have this outer class, and it has a test at the top level. It has a subject under test. It's the stack. And then we have an inner class here, nested, right? And when new, and then it actually creates a stack, and it's before each. And then we see somewhere further down, after pushing, that actually has a before each that pushes an element on. So we can execute that and see what it looks like. And that would look something like this. Let's expand all and take a look. So there you see, right? You have the various levels and the custom display names. So you have basically a way to read that nicely with the custom display names kind of BDD style. And if you double click anywhere, you of course jump straight to the code. And that works in IntelliJ and in Eclipse. All right. So testing templates, I mentioned those are a bit more advanced. Basically, that's anytime you want to have a test method serve as a template to be executed multiple times with various different input. And a common example would be a repeated test. You just want to have it run multiple times. So you can annotate a method with repeated test instead of test, and then specify the number of repetitions. And then you can optionally have the repetition info injected if that's useful for you as a method parameter. And you can also optionally override the display name for some custom display names. So here's an example here, 2 examples. So we have repeated test 5 at the top up here, and taking the repetition info and just checking what it is, but basically it'll just run that test multiple times. And here we have another one where we are changing the name. Maybe you want to change it to, this is German, Spanish, something else, or you might want a shorter format. So this would end up printing out stuff like Wiederholung 1 of 1 und 2, so 1 of 2 and stuff like that, instead of the default. So that's a core feature we have now in JUnit Jupyter. And the other thing we have is parameterized tests. So that was a feature in JUnit 4, but much less powerful and much more cumbersome to work with. So this is kind of inspired by JUnit params. You might have seen that, an external third party. And now what we have is @parameterized test you'd use instead of a test. And you specify the source of the arguments, where they come from, optionally overriding the display name like with repeated tests. And in terms of these sources, we have lots of different options out of the box. First up, we have value source for some static values, strings, int, longs, doubles, stuff like that. You can also have enum constants supplied as your parameters, or you can specify a method source, and that would end up being a static factory method where you actually programmatically determine what parameters should be passed to your parameterized test. We also have support for CSV, so common separated values. You can have that inline, or you can actually have it pulled from a file in the class path if you have some existing CSV files you want to use there. And then if those things don't work for you, you can use @argument source and implement your own arguments provider and decide programmatically how you want to build up the arguments passed into your parameterized test. So a lot more functionality, a lot more flexibility than what we had in JUnit 4. So this argument conversion also borrows some notions from Spring, right? So we have implicit conversion based on primitive types and the wrappers, string, int, stuff like that. We also have support for enums for the constants, support for Java time, like local date time, stuff like that. But then there's also support for explicit conversion. So you can specify your own converter, an argument converter, passed in via @convertWith for a particular parameter. So if you want to convert from a string into some other format, maybe from JSON. I've seen an example out there. Somebody wrote a JSON converter that uses the Jackson mapper and takes JSON input and then creates an object graph and passes that into the test method. So lots of options there. And if you want to use a different pattern than the default patterns that we have for Java time, there's a Java time conversion pattern that you can use as well. So what does that look like? That would look like this. We have @parameterized test, and at the top here we have @value source, specifying an array of strings. These are all candidates for palindromes, right? So you can read them forward and backward, and this test should then pass because they are all, in fact, palindromes. So I'll just show those running in action. We have the repeated tests. Well, maybe for time, I'll actually show the already implemented version. How about that? Right, so I mentioned here we have @repeated test, accepting repetition info if we want. Here, repeated test and converting it to German. So we have some placeholders for current repetition, total repetitions, and if I were to run this, we would see something like this. So I mentioned these things are test templates. That means the actual test methods end up being a template, they end up being a container like your class, and then all of the actual executions end up below that. So we see here, this is the by default repetition 1 of 5, and then in the German version, Wiederholung 1 von 5, so stuff like that. So that's the repeated support, and the parameterized support, we have that as well. So here, I showed the one on the slide with the value source, but here I've switched it to a method source, and this is the name of the method. This is the static factory method here. It returns a stream of strings, and these are the candidates that we think should all be palindromes. So if we were then to execute this, we would see something similar, right? So that's, again, the container is the test template there, and then when we see the results there, and the number at the beginning is just the index of the invocation, and then the actual parameters that were passed in. So you see you have quite a bit of power there. Okay. So lambdas as tests, right? We ended up, we started off calling it JUnit Lambda, right? That was the code name for the project, and we have, in fact, brought in support for using lambdas in the form of what we call dynamic tests. So everything we've seen so far is static, more or less. You might consider the parameterized test not really static, especially if you have like a static factory method that's generating the input on the fly. But we'll see with dynamic tests, it's really, truly dynamic, right? So at test would be static, and with now we're going to have as a dynamic test registered at runtime as a Lambda expression or a method reference. And basically, we provide them as a stream or as a collection. We also have support for dynamic containers, so you could have nesting in your structure there. So you can have dynamic containers with more dynamic containers and eventually some dynamic tests. And the way you do that is you just annotate a method with test factory and return a stream of these things. So it's somewhat analogous to the parameterized tests, but more dynamic in nature. So here we have an example. We have this at test factory, and the method is here returning a stream of dynamic test. Again, you could have returned a dynamic container or dynamic node if you wanted to. And here we're just using instream, and we're going to find the first even 10 integers. So starting with 0, iterating, n equals n plus 2, limiting that to 10. And then for each number, we will map it onto a dynamic test, right? So that's how we're building up the stream. In this case, the first part is the display name, test plus n, right? And then this is actual code block. This could be a longer code block if you want. It could be a method reference for some method you already have in your test class, et cetera. But that's basically the body of your test. So that's the test name and the body of the test, and you can build this all up dynamically. So what would that look like at runtime? Here, I have some other extensions. Let's just comment this out for a second. So here we see test factory, the first 10 even integers. That's the one we just saw before. And here we have a different example with stream of strings here. So if we were to run those, see the output. It's similar to what you saw with the parameterized tests, et cetera. So we have the containers for the test factory methods, but then the actual invocations are the Lambda expressions and the names that we built up dynamically. So that's all with Lambda expressions on the fly. Okay. So what's missing? Support for what we like to call scenario tests. So if you know frameworks like TestEngines, like you can have dependencies between test methods, and maybe you want to have shared state. So we already have the support for having the test instance cached, and we're going to add later on support for having dependencies between the methods so you can build up like a scenario with multiple steps. Another feature that's missing, you can't currently order the methods or change the order in which they're executed. Parallel execution, something we're going to look into, and also execution and user-defined threads. These are some more advanced use cases that we just didn't have time to get in for the 5.0 release, but we're working on some of them in 5.1, and some will probably come in 5.2 as well. And another thing is the support for suites. So JUnit 4 has support for suites, and in the platform we actually have support for suites, but it only works if you're using the platform, JUnit Platform runner. So we want to build an actual first-class declarative and programmatic support for building test suites for the platform as well. Java 9 module path scanning, again, that's already available in a milestone, but that'll be in 5.1. So I think I will skip that and go into the Spring stuff. I might come back for that if we have more time. So Spring 5 and JUnit 5, right? Match made in heaven. So Spring support for JUnit Jupyter itself. We have, it's fully integrated in Spring Framework 5.0. And that pulls in all of the standard support we've always had for the last 10 years for the Spring Test Conditional Framework. All the features that worked previously or in TestEngines or in JUnit 4 also work with JUnit Jupyter. But in addition, we now have support for constructor injection and method injection from your Spring application context, right? So you can use things like @AutoWired, @Qualifier, @Value, or just specify like the application context and have that injected in. And we also have support for conditional test execution. Again, this new feature from JUnit Jupyter, but implemented in Spring with spell expressions. So we'll look at that in a minute. Also, we have some new annotations for configuring the application context and combining that with JUnit Jupyter at the same time because of the new meta annotation support. So if you're on Spring 4.3, which I assume a lot of people probably are, you can actually use most of the support, all of it except for the conditional test execution is available as well. Unofficially, it's not published anywhere, but it's in my GitHub repository, and if you want to access that, you can use Jetpack. There are instructions in the README there for how to use that in Gradle or Maven, so there are actually people using the JUnit Jupyter support with Spring 4.3 as well. So how do we configure JUnit Jupyter with Spring? We do that with the Spring extension, right? So JUnit 4, we had the Spring runner, and now we have the Spring extension, and you just say @extend with Spring extension, and that's it. And you have the automatic support for the for Spring's testing framework with all of the other annotations, and you can just combine them. But we have some shortcuts. So if you want to type less, you can say @Spring JUnit config, and that combines the @context configuration annotation from Spring and the registration of Spring extension. Similarly, for the web support, we have a Spring JUnit web config annotation you can use, and that combines the previous two plus the web app configuration support. So if you want to load a web application context, for example, to use with MockMvc or something like that, then you can do that as well. And we have these very powerful annotations for conditional test execution. We have @enabledIf and @disabledIf, and they both take spell expressions. So you can work with anything from like system properties and environment variable, but you can also access beans from the application context if you really wanted to. To do that, you'd have to turn on a flag. That's not enabled by default, but you can, in fact, interact with beans to decide whether or not a test should run. So very powerful options there. So quick example. We've got, well, we have maybe, yeah. So Spring JUnit Jupyter tests, right? So if we wanted to use Spring extension, we would just specify it like that. And if we wanted to make these tests, right, make sure we pick the ones from JUnit Jupyter. So far so good. We see this final primary cat. So how can we access that? Well, let's just start off. Let's do it kind of the old school way. What if we did it auto-wired and just commented that out, right? Then we would have the primary cat. That should hopefully fail because we haven't specified the context configuration. That's what it's saying. There's no application context. So how could we actually define one of those? We could pick context config and specify classes equals, and I have something called test config, I hope. All right, so what does that look like? That has 3 cats in there. One of them is primary, Catbert, and the other one is Garfield. So that should work out hopefully now if we run this. Yep, it's there. So everything loaded up, and we could check, right, maybe assert equals. Yep. Expected, what did we say the first one was? Catbert? Catbert and primary cat get name. So we're assuming that works as well. Let's try that. It does. That's green up there. So what I was saying about this auto-wired, you could, if you wanted to, have it passed straight into the method. Like that, if you wanted to. You could. That works now if you're only using it in one method. But I would say if you're using it in several places, maybe like the order service, maybe it's your order service tests, then you want to use it everywhere, then just move the auto-wire down to constructor, and you can make this thing private final. So you can have immutable state in your test classes now, right? So this is now immutable. We pass it in the constructor, and this test should hopefully still run. And it does. It's still green. So what if we wanted to get the qualified cat? There are 2 cats, right? So you could just say, you don't have to say auto-wired and qualifier. You can just say qualifier. And what was the name of that one? Should be Garfield, I think, something like that. That should work as well. So the qualifier works here as well, or not. What have I done? Oh, thank you. Then that wouldn't work. All right. All right, so that's green, so that works as well. And if you wanted to get all the cats, you know, you could auto-wire in a list of cats. Not a well-known feature in Spring, actually, but you can get a whole list of them. Short equals, and I'll just check the size. So I'm assuming they're the size should be 2, right? There should be 2 cats in the application context. And it's all still green. Okay, so what was I saying about you can actually simplify this? Spring JUnit config, and then you can just type even less, something like that. So that should also pass. So some highlights there, right? Simplify configuration. This combines, as I mentioned, registering the Spring extension with JUnit Jupyter, and also specifying or extending from @context configuration from Spring 4.3 support. So we have that. Things don't have to be public. You can auto-wire in constructors, auto-wire in parameters to your test methods, use qualifiers. You can use @value, spell expressions, and stuff like that if you want, and everything works very nicely. Say again? It is. There's some debate about that. But it's required because the reason is that you might want to combine it with other stuff. You might want to pull in things from other places. Like you might want the test info from JUnit. And then if you specified that, and by default, you wouldn't want to have conflicts with other parameter resolvers. You might be using Spring with other things or getting access to stuff like the test info or the test reporter and things like that. And then Spring couldn't provide those. And if you had auto-wired, Spring would do that automatically, then it would throw an exception. Yeah. So yeah, that works like that. Whereas my assumption is that, yeah, if I go like this, I haven't tried it, should throw an exception. Yes, because Spring doesn't know anything about or there's 2 competitors, right? JUnit says it handles that, and Spring says it also handles that because you put out auto-wired there. Okay.
I think you was maybe referring to how, like in 4.3, like you don't have to put auto-wire on SQL.
I'm familiar, yeah. So the testing framework dependency injection is not the same as the core dependency injection. Yeah, I understand the question. Yeah, you can leave that off in your application code, but Spring doesn't instantiate the method here. There's maybe a misunderstanding there. So it's actually JUnit that's instantiating it, and Spring just ties in and says, I'm a parameter resolver and I know how to resolve things, but I only resolve things I'm supposed to. And Spring doesn't want to conflict with other parameter resolvers unless you explicitly say @autowired. So it plays nicely with other extensions out of the box is kind of the point or the answer to that. And yeah. Just make sure this works again. I wanted to show the disabled if, right? So again, disabled on Mac, right? Now if we run that one, it should be disabled like it was previously. Another example, right? So one skip, that's correct. And this disabled on Mac, that's just a custom annotation I've written. I can use it on types and methods, so the class level, method level, and I'm using this disable if annotation from Spring, and then specifying an expression. So here I'm checking system properties. If the OS name lowercase contains Mac, then it's disabled on Mac, and otherwise that would return false, right? So then it wouldn't apply. So that's what I meant by you have this power to create your own custom test execution conditions on the fly with spell expressions. And again, you could also access a bean in the application context if you really wanted to. Okay. So Spring Boot, since 1.4, as when I first started testing, Spring Boot 1.4, 1.5, and 2.0 snapshots, they all work fine with JUnit Jupyter. So basically you can have some custom config. I have an example using Spring Boot test and the auto configure MockMvc, and then the extend with Spring extension. Combining that into one custom annotation here, one composed annotation, Spring events web tests, which comes from my Spring Events example app in my GitHub repo. And if we wanted to see that in action, we can. So we see Spring Events web test, simplifying all the configuration from Spring, Spring Boot, and JUnit Jupyter together, having a JUnit Jupyter test, custom display name, auto-wiring in the MockMvc that's automatically created by Spring Boot, right? And then you can just set that, use that thing locally, right? So that should actually work as well. Let's check that out. So I have a, where is this main? I have a Spring Boot application, not very exciting, but it's a Spring Boot application, and it has the same two cats, primary cat and the secondary cat. And I have a working example with the Spring Boot Jupyter tests somewhere. Here we go. So this is Spring Boot test, specifying the application, extend with Spring extension, and then auto wiring, and we see that Spring Boot works as well. So we should see the Spring Boot logo, and then everything should pass. And again, that the web example there was from Spring Events, and that would look something like this. In the web area, I have this Spring Events web test, custom annotation, right, combining Spring, Spring Boot, and Spring Transactional. And then for the actual test, I have an example here with the events controller with that custom annotation, auto wiring in the MockMvc, and that might take a few seconds, but it'll actually launch the entire Spring Boot infrastructure there, Spring Boot test, and then auto wire that configured MockMvc in. And test the controller. Taking a few seconds, even interacting with the embedded database. So end-to-end testing there, and we see that it actually passed. Okay. So in closing, if you check out the slides later on, I have links to various resources for JUnit 5, right? The homepage, JUnit.org /JUnit 5, the user guide, pretty thorough. I recommend you actually check that out. Actually read through it. It's not too long, but lots of information there. Lots of examples. All the examples actually work. They're compiled and tested along with the build. Java Docs Online, GitHub. If you have any issues, contact us. You can chat with us sometimes on Gitter or ask questions on Stack Overflow. And similarly for Spring resources, hopefully you know where to start there. Start at spring.io. And if you want to see the demos, this stuff was up all online in my account, sbrannen JUnit 5-demo. So, do we have time for some questions? Or, yeah, I think so. Anyone have any questions? Yeah?
So, like, do you have support for the SoFar plugin, or is support for a fail-safe plugin coming as well?
Not from us.
Okay. Or, I mean, or even not from you, but like, have you heard like information?
I haven't heard anything. No. Just the Surefire team, yeah, supposed to be taking over.
Okay.
Yep. Say again?
In that repeat test, you had an assertion that you 4 or 5 times.
Yeah, that wasn't a very plausible example. Yeah. It would be executed each time, yeah. Just the total number of repetitions was 5. It was just a demo to show that you can inject the repetition info. It wasn't a very meaningful example. I mean, you probably want to test something that's potentially flaky and maybe fails sometimes, or maybe you want to do something based on the incrementing number, perhaps, something like that.
Why would the 5 that method's called 5 times?
No, because it was the total count, not the current count that I was asserting. I'm not sure which one I have there. Well, no. Yeah, it was it was checking the total repetitions as 5. So it's just basically saying 5 is equal to 5.
So that's the constant.
Yeah, that's always 5. And the other thing would be current repetition would be 1, 2, 3, 4, 5. Yep. Okay. Yep.
The parameterized tests, does it support multiple parameters?
Yes, definitely. I just didn't show any, but we have in the examples from the user guide. Hold on, let's see. You should be able to see all sorts of stuff. So this is the same example I had with the palindromes with multiple arguments. Where do we have one with multiple arguments? Somewhere at the bottom we have, yeah, this takes a string and an int and a list. So for example, if you run that, you see that it took multiple arguments, and then you see all the names listed there. Yep. Yep. Okay. I think we're about to take it outside. Oh, one more question? Yep.
For your exception test, why was it still running red after you were verifying the exception in this message? Like, why wasn't that test green?
It was, but the timeout was failing. Maybe you're thinking of that. The final state I left it in, the timeout was failing because I had it checking 42 Fibonacci that was taking too long. But the exception one, it was passing as the exception was thrown. Yeah. Okay, do we have to shut it down? No responses? All right. Okay, thanks for coming.